Hey everybody, it's Miss Smith. So today we are going to officially start Unit 3. Now this is the unit that's going to take the longest. It's not the hardest one, there's just a lot. And so we're going to cover chemistry naming and what they look like. What do compounds look like in 2 dimensions and in 3 dimensions? Now, the chemical naming is the one that's going to take the longest. There are quite a few rules, but I'm actually going to take it super slow and one little bitty step at a time, and to make sure that you master every single step, because the beginning steps help you master the second step and the third step and the fourth step, and on and on and on. So I've got to make sure that you understand it every step of the way. So I'm going to take it super slow. We're going to do one concept at a time. You will be fine. Now, something that is a very common mistake, very, very common mistake, is when we're dealing with Roman numerals. Now, I know you don't know what that is, what I'm talking about yet, but there's a way that I have devised to help you, to keep you from making this mistake, because people make this mistake all the time. So what I want you to do is I want you to pull out this periodic table that I gave you. I actually took mine out of the protective sleeve. I want you to pull out this periodic table. And so last unit, you labeled this periodic table, and you know, the 1s, 2s, all that stuff, the electron configurations. I want you to turn your periodic table over, and I want you to highlight some of these things on this periodic table. Now, the highlighted ones are what's going to help you, because I will refer to this throughout the unit and say, you know, is it a highlighted one? Is it not a highlighted one? So you've got to have it highlighted so you know what I'm talking about from then on. So what I'm going to do, I'm fixing to turn my camera around and it'll show you which ones, and I'll show you why I highlighted them. There are 30 elements to highlight. So let me switch my camera around. All right, there we go. Now, so what I want to show you is, let's look at cobalt. It's trying to focus on cobalt right now. You see that cobalt is split in half, and that it says cobalt 2 and cobalt 3, those are Roman numerals. That's what I need you to highlight. All of those ones that are split in half like that. So you see how cobalt, it's got cobalt 2 and then cobalt 3. So that's split in half. So all of the ones that are split in half need to be highlighted, and there are 30 of them. So if you want, stop this video on this image right now and go ahead and highlight these. It'll take you just a few minutes. So today we're just going to go very slow, so go ahead and highlight those if you haven't already. Please, please, please do this, just like how you had to label the periodic table for last unit. You have to highlight these, okay? This is going to help you so much, okay? It's such a common mistake. I even make this mistake sometimes, okay? So please do it. All right, so we're going to go ahead and get started. What I want you to do first thing is we need a big old Unit 3 here. Just real big in your notebook. All right, and let's go on to the next page. All right, so first thing that we are going to do is naming monatomic cations. Now, there are quite a few words that I just said that you may not know what they mean. So let's talk about this. Naming monatomic ions. I went a little crazy with the all caps there. Sorry, I know this bothers some of you. Monatomic ions. Now, let's break these words down for just a second. We know that an ion is anything that has a different number of electrons than the neutral atom. So it means it has a charge. -1, +1, +2, +4, +8, -1, -7. Whatever it is, it means that it has a charge. That's what an ion means. Now, let's look at this. So this here. Mono means 1. Atomic means atom. So this means 1 atom. Okay, we will be dealing with things that are polyatomic, so many atoms. So what we're dealing with right now is a single element that has a charge. So that's what this is, a single element that has a charge. That's what the translation of that is. All right, so let's get into a couple of examples here. And you are going to need your periodic table, the one with the ions on it, so have that handy. I'm not really going to put it on the slides because you're supposed to have that in front of you. If you do not have this periodic table, I'm going to stress this over and over and over. You need this periodic table. You will fail this entire unit if you do not have this periodic table. So if you have lost it, please contact me. I will print you another one. I will hand deliver it to your house if I have to. Okay, you have to have this periodic table. There's no other way around it. I actually had a student that's at ULM right now that graduated last year. She emailed me and said, Miss Smith, I need this periodic table to pass my chemistry class. So I sent it to her, okay? I have been teaching this class for many years, and I have found the easiest way to teach these things. This periodic table, the one with the ions, the one that you just highlighted, is going to help you pass this unit. Please make sure that you have it. If you don't have one, you lost it, that's fine. I will print you another one, not a problem. I just need you to use this periodic table. You've got to have it in front of you. Okay, so let's go ahead and let's talk about a few examples. So I'm going to give two things right here. I'll give you three actually. So I've got Na plus, I've got Sr plus 2, and then now on your periodic table you may see it put as 2 plus 2. At this point, one's a charge, one's an oxidation number. It's not really important that you know the difference right now. We're not really going to get into oxidation numbers. You don't really need to know them. There's a way that I teach that. You don't need to know that. I actually kind of skirt around oxidation numbers. There's a way to teach it without knowing oxidation numbers. So anyway, don't worry about that. Don't worry about if it's plus 2 or 2 plus. Doesn't matter at this point. Okay, and then the third example is Zn plus 2. Okay, so sodium, go to the periodic table. You know that this is sodium, but sodium is just Na. We are trying to name Na plus. So this is not just sodium. This is sodium ion. Two words there. So Na is sodium. Na plus is sodium ion. You have to have that word ion after it when it's not attached to another element. When it's an element by itself and it has a charge on it, you have to put the word ion after it, okay? We have to signify that there is a charge on this atom. Same thing with strontium. Sr is just regular strontium, but Sr plus 2 is strontium ion. Now, this next one, zinc. This is not just zinc. Zn is zinc. We are dealing with zinc ion. That's what we're dealing with. Okay, so fairly simple. Let me give you a couple of examples. Let me write down 3 examples, and then we will go on to the next step. So what I'm going to do, I'm going to give you 3 examples. I want you to do Li plus, I want you to do Ag plus, and I want you to do Ca plus 2. So go ahead, try those out. Go ahead and pause the video and try them out. Okay, hopefully you tried this out, and so let me give you the answers real quick. See if you can check yourself. This is lithium ion, this is silver ion, and this is calcium ion. Now, if you did not put the word ion at the end, you have to put the word ion at the end. Okay, there's no way around that. Okay, so we're done with that little section. Let me teach you Roman numerals now. Okay, what happens if you come in contact with a ion that has more than one charge option? Oh, that was something I forgot to talk about. We said the word cation earlier. All that cation means, all that this means is a positive ion. So I actually look at the plus sign here. It means that this is a positive one. Cation is a positive ion. That's all that that means. Okay, an anion is a negative ion. Okay, pretty simple. So this one is going to be ions with Roman numerals. Okay, so let's go into this one. Here's a couple of examples. Fe plus 2 and Fe plus 3. Pb plus 2, Pb plus 4. Okay, those are a couple of examples. So if you go to your periodic table, and you've already got it highlighted like I told you to earlier, you will see that iron is one that is highlighted. What that means, if it's highlighted, is that you need a Roman numeral. So if you're using this periodic table on an exam, which you'll be allowed to use this periodic table, the one that you've highlighted, you'll be allowed to use it on the periodic table. When you do this and you look to see what the charge is and you see iron highlighted, that should be automatically saying, oh, I need a Roman numeral. So that helps you remember that you need a Roman numeral, because even I make the mistake and forget to put a Roman numeral. If you need a Roman numeral and you don't put it down, technically the answer is incorrect. You've got to have the Roman numerals. The reason why you've got to have a Roman numeral is it actually says which charge you're using. So iron has 2 charge options. It could be iron plus 2, could be iron plus 3. So we have to say in the name which one we used. Okay, so this is iron plus 2. So this is simply, let me do this in red. So this is simply iron 2, Roman numeral 2 in parentheses, ion. And that's it. So this 2 came from here. That's where that came from. Not hard. Okay, it's just remembering that you've got to do this. So iron plus 3 will be iron Roman numeral 3 in parentheses, ion. Same thing with lead. This is going to be lead 2 ion, and then lead 4 ion. Okay, if you need some little side notes here, let's talk about Roman numerals real quick. So Roman numeral 1 is a single I. This is Roman numeral 2, Roman numeral 3, Roman numeral 4, Roman numeral 5, Roman numeral 6, Roman numeral 7, 8, 9, and 10. You will not go over 10. Okay, that's 1 through 10. So just put those somewhere in your notes. If you need to go back to them, you can. Okay. All right, so let me give you a couple of examples and to see if you are correct. So a couple of examples are Cu plus 2, Sn plus 4, and CO plus 3. Okay, so go ahead and pause this video, answer these yourself, and we will come back and answer them here in just a minute. Okay, hopefully you answered these. So this is a +1 on this copper, so that's going to be copper, Roman numeral 1 ion. Now this is a +2, so Roman numeral 2 ion. Sn plus 4 is going to be tin 4 ion, and then this will be cobalt 3 ion. Okay. Now, there's one more thing that I want to talk about is this is the last topic that we're going to cover today. Naming naming monatomic anions. Okay, so let's break this down again. Mono means one, atomic means atom. So this is one atom with a negative charge. Okay, so anion stands for the anion stands for a negative charge. Cation was a positive charge, so the anion is going to be negative. Now, the rules for these are very different than for cations. Okay, so here's some examples. So this by itself is just oxygen. Okay, but if you do O minus 2, that's no longer oxygen. Now, according to the rules we did on cations, you would think that the answer to this would be oxygen ion. That it is not. Negative ions or anions get something completely different, okay? You actually have to change the ending of the name to IDE. So this is not oxygen anymore. This is oxide ion. I'll give you another example. N is normally nitrogen. This is going to be +3. Nitride ion. Okay, now some of you are like, well, where do I cut it off? Where do I know to put the IDE? Okay, it's really whatever sounds correct. Okay, I'm just happy the fact that you remembered that it was supposed to be IDE at the end. I'm just happy with that. Now, whether or not you spell it correctly, half the time I spell mine incorrectly, so it's fine. I'm really just happy that you found that you remember that it should be IDE. So here's a couple of examples. Let me do another one. Let's do F minus. Now, on your periodic table, if you're looking at that, because this is the periodic table of ions, not just the regular periodic table of elements, these have already been renamed. The negative ones have already been renamed to the negative ions already. So F minus will be fluoride. Now, you still need the word ion at the end of it. Another example would be S minus 2. So that would be sulfide ion. Now, you may see this spelled S-U-L-P-H-I-D-E. That's fine. There's two ways to spell sulfur, one with an F, one with a PH. Either one are acceptable. Now, some of you are probably like, well, shouldn't you have a Roman numeral on sulfide? No, because it's not highlighted on your periodic table. You only need a Roman numeral when it's highlighted on your periodic table. That's the only time you need that, okay? So don't overuse it. All right, so that's it for the lecture today. Let me know if you have any questions. You know where to find me.